Welcome to Test Yourself and welcome to the revision series for GATE Metallurgy. So this is an introductory video and this is me, myself Hritudipan Pradhan. I have secured an All India Rank 1 in GATE Metallurgy 2024 paper and I have completed my Bachelor's of Technology in Minerals and Metallurgical Engineering from IIT ISM Dhanbad. So yeah, this is all about myself. Now, before moving ahead to discuss about this course flow and course structure, let's first understand the importance of this revision series or importance of revision in general. Okay, so what is the reason for doing such rigorous revision in a competitive exam like GATE? So, to illustrate this, I have taken a question. So this is a question from GATE 2023 Metallurgy, which is related to engineering mathematics and specifically the differential equations. Okay, so let's first try to understand this question. So we need to find out the order and degree of this differential equation, where dy by dx raised to the power 3, that is equal to root over of d2y by dx square plus 10. Okay, so these are the options now. Okay, so let's take the first case where we have not yet done the revision of it. So this is the first case, that is not revised this topic. And now let's discuss the possible reasons for not revising. So the first reason for that can be overconfidence. So it may be the case that you are so much confident about this topic that you forgot to revise, or in fact you decided that you should not revise this topic because again you have a much confidence and that you have a proper grip over this topic. Okay, second, due to this overconfidence and if you have enough time to revise, you may revise it very quickly. That means you may just open your notebook and turn the pages around quickly so that you will get a satisfaction that you have revised it very properly. But you have left some important points, like here in this question about the order and degree. So these two terms quite seem to be very easy concepts, right? It is in fact easy if at all you remember what the degree and order is. So it seems easy at first look or first glance. So you just left that topic and turned your page around and moved to the next. Okay. So that is in fact you revised it very quickly. The third reason of not revising is not getting enough time to revise. Yes. So it happens in most of the case that we do not keep a record of our progress in syllabus completion and the time left for the final day of the exam. As a result, we go on studying new concepts and practicing questions when the exam appears to be very close, but we do not give much importance to the revision. Okay, so that is in fact when you not get time to revise. So that in fact may be or that will lead to a consequence of revising quickly, and that can be due to overconfidence. So all these three are related, and that can be the reason of not revising. Okay, so let's now see if you have not yet revised this topic but you encountered this question in the exam. Okay, so let's say if you have encountered this and this is the particular equation given to you, right? So now what happens if this question is given to you and you have not yet revised? So what will be your approach to this question? First, the first and foremost approach to this will be you will look at the options, which is one of the you can say it's not a good habit to look at the options first if that question is a solvable category. Okay, so this question you need to first of all solve, then you need to look at the options, but you looked at the options first, so that can be a possible source of doing a mistake. Okay, and second thing, now let's try to solve provided we have not yet revised. Okay, so let's say uh, the degree of this differential equation. Okay, so the degree of differential equation, if I have not yet revised, but I know the topic in a bit detail, right? So let me think, what is degree? Yes, so degree is something raised, means the highest power to which the differential equation is raised to. So that type of definition will come in my mind during the exam, because we do not have enough time. So this is what I will remember. Okay, so it's highest degree to it is raised to. So degree should be 3. Okay, so let me first solve. So degree is 3 now. And order I know that the highest order to which the differential equation has, right? So d2y by dx square, or the highest power of dy by dx, you can say. So not exactly its power, but the nth derivative, so that refers to the order. So highest order of that n will give us the order of that equation. So order will be 2. So order will be 2 and degree will be 3. But now when you look at these options, you will not find any 3 option written there. Had it been the case that the options like 2 as order, that is O equal to 2 and degree equal to 3, might have been given in the question, then in a hurry you might select this option, and there you go, you lost 1 or minus 1 mark there. Okay, if it's a single choice question. So that in fact will be called as a blunder, because this topic is easy, and these are the possible ways in which you will be doing wrong in the exam. So what are the consequences of solving this question like this? So these are the following consequences. So first consequence is you may select a wrong option or may write a wrong answer. Let's say if it's a numerical answer type question and options are not given to you, and the question asked is to find out the sum of the order and degree, right? So order plus degree will be what? So if you have approached this question in this particular manner, then the answer to it will be 5, right? But the correct answer to it is, I'll come to, you will get to know the correct answer once I will discuss the case 2. But let's first discuss the second consequence of not revising and solving this question. So tendency to not leave this question will also arise in the exam hall. Yes, that's a very important point, because this question itself seems to be very easy, and you will have a particular kind of notion that every student in the exam will definitely solve this question. It was my case that I have not yet revised, but I will try to solve this question, and I will not leave this question and move ahead, because this question is very easy. And this is the tendency which I have even faced during my uh, practice sessions and test series which I used to give, and even in the exam hall also, even after practicing so much. Okay, so the tendency to not leave this question will also lead to loss of time. So the first consequence led to loss of marks, and the second consequence led to loss of time. So time in the exam is very important, because you need to save your time in order to recheck, re-verify your solutions, as well as in order to solve the unsolved questions which you have marked in the marked for review in the exam. Okay, so you cannot compromise on these two aspects in the exam hall. So it's better if you revise properly. Now let's take the second case where you have revised it. Okay, so this is the second case where we have revised. So if we have revised these topics, then we will be first confident that we have revised, so we know each and every aspect of this particular topic very firmly, very confidently, right? And second, if we have revised it thoroughly, that is, we have revised each topic in a very detailed manner. Let it be a very basic to basic part in this topic, like order and degree. It seems very basic, but if you revise it, then you will be able to solve the basic questions as well. And you had enough time, so you have planned your revision in such a way that you have finished the syllabus, and irrespective of you have finished 100% or 80% of your syllabus, you have dedicated some time to revise as well. Okay, so considering these three aspects you have revised, then what definition of order and degree will you have in your mind is this: That is, the order of a differential equation is defined to be that of the highest order derivative it contains. So the degree of a differential equation is defined as the power to which the highest order derivative is raised. But the powers should not be the radicals or fractions. Okay. So the degree of a differential equation is what? It's the power to which the highest order derivative is raised, and the highest order derivative is the order of the differential equation. So the order of the differential equation will be 2. That is no doubt, right? And the degree, for knowing the degree of the differential equation, we know that the power to which the highest order derivative is raised, and that power should not be in fractions. So here we can see that d2y by dx square is raised to the power of 1 by 2, right? And for converting it to a whole number, we need to first of all square both of the LHS and RHS. So if we square this, what we get is dy by dx whole to the power 6. That will in fact give us d2y by dx square plus 10, right? So now the differential equation has been converted to a form where we can determine the order and degree as well. So the degree of this is 2, that we have already discussed, and the order to which it is raised is 1, right? Because it's not even a fraction, it's a whole number 1. So the option A, that is order of 2 and degree of 1, will be the right answer to it. Okay. So now let's see the consequences of fully if we have done the revision fully and we have solved it with a lot of confidence. Now let's see the consequence. So we have again two consequences. So we have just looked at the option only after solving. So we have first of all solved the question and then we looked at the option instead of completely relying on the options if we had not yet revised. Okay. So here we gained marks, and tendency to solve in confidence, that also came. Along with that, we saved a lot of time and we invested that time in solving and rechecking. So that time which we had used or utilized in thinking about what concepts we had not revised, and we were just looking at the options and marking the correct answer instead of spending time in that, we invested our time in solving and rechecking. And that should be the ideal scenario for solving the question, right? And utilizing your time properly. So this is the importance of revision, which I have tried to explain in this question. Now let's discuss one of the concepts and we will again come back to a question. Okay, so here we have a concept of frictional loss in a fluid flow. So this is a part of the notes which I have created for during my revision stage. So here I have written the frictional loss or head loss in a pipe. Okay. Before discussing the frictional head loss, let me first of all introduce what a flow through a pipe is. What exactly it is. So if we see the cross section of the pipe, it will look like this, right? Circular in nature. Now we will only consider the flow as a flow through pipe only when the water is completely filling the cross section. Okay, so this particular condition will be considered as a flow through pipe. On the other hand, if we see the flow to be like this, where only a certain small region is containing the water and the remaining region is blank, that is its air, then that will be in fact considered as a flow through an open channel. So that will in fact look like flow through a flat plate. So if we have a flat plate here, then the fluid flowing is in fact a flow through the open channel. Okay. So here we are dealing with this particular condition, that is a flow through pipe. Now if we consider the pipe flow like this, then the fluid entering this pipe will have certain energy associated with it, right? Because if we see the concept of hydro energy, that is, we convert the potential energy of water to that of the kinetic energy to run the turbines, right? So there we are associating the flow of that particular water with a kind of energy. So here also we have to associate the flow of this particular fluid inside of a pipe with a kind of energy. So that particular energy will in fact contain three major aspects, that is kinetic energy, potential energy and pressure energy. But that particular energy can be written in terms of energy head. So that unit will be in fact in units of length instead of joules. Okay, so instead of joule we will write meter. So if we consider that let's say this particular energy associated with the fluid flow, where the fluid is entering from this end of the pipe, let it be x joules, then the corresponding head in meters or in units of length, let it be y1. Okay, now let's say if this particular energy in second scenario, let it be y joule, where y will be greater than x, then the corresponding head and associated with this y joule will be, let it be y2. So if y is greater than x, then y2 will be also greater than y1. That means we are just correlating the units of length with that of the energy. Much similar to the case when we associate the pressure, let's say atmospheric pressure, with the level of mercury, or the height to which the mercury level is reached. That is, we write 760 mm of Hg, that in fact is equal to 1 atmospheric pressure, right? So in similar way we are associating the units of length with that of energy. So what happens in real scenarios or in ideal cases, there is no such energy loss which is happening. Let's say if this particular part has an energy head of y1, then the fluid that will come out from this particular pipe in ideal case will also have the energy head of y1 only. But in real scenarios we know that not every surface is completely smooth in real cases. So there will be some form of energy loss due to the friction which is happening inside this particular pipe due to the walls of the pipe, right? So there will be some frictional energy loss, and that will be in fact called as a frictional head loss in the pipe, which will be in fact having the units of length or meters. Okay, so that particular expression for the frictional head loss inside this particular pipe will be given by the Darcy's-Weisbach equation, which is given by this formula HF, that is frictional head loss in meters, will be in fact 4FLV square by 2GD, where small f is the friction coefficient, L is the length of the pipe, total length of the pipe, okay, V is the average velocity of the flow in the pipe, and D refers to the diameter of the pipe. And if we consider another term, that is friction factor, which is 4 times the small f, that is friction coefficient, then that will be in fact written by capital F, that is related to small f by capital F, is equal to 4 times small f. So we can rewrite this equation as FLV square by 2GD. Then that will be in fact equal to FLQ square by 12.1 into D to the power 5. Because if we consider the flow rate here, that is in fact Q, whose unit is volume per second, that is meter cube per second, let's say, that will be in fact given by area into velocity, right? So area will be, let's say, in meter square, and velocity will be meter per second. So that will in fact give us meter cube per second. So we can replace this V by writing Q by A in this particular expression. And V square will be Q square by A square. And A we can write as pi D square by 4. Right? So replacing all these or substituting all the values in this particular expression, we will get this. Okay, FLQ square by 12.1 into D to the power 5. So 12.1 has come from multiplying the constant terms. Now, the value of small f is given by 2 times tau naught by rho into v square, and capital F is given by 4 times of small f. So that will be equal to 8 times tau naught by rho into v square. Okay, where tau naught is the wall shear stress. Now, this particular f will be different for both the turbulent flow and laminar flow. I'll discuss in detail what turbulent and laminar flow is in the revision series. But for now, Just consider that these two types of flow are different type of flows which occur inside a pipe, and turbulent and laminar flows are determined using a Reynolds number. So if a particular value of Reynolds number exceeds a critical value, then that will be in fact called as a turbulent flow, and if it is inside that particular range, it will be called as a laminar flow. So for a laminar flow, the value of capital F is given by 64 by Reynolds number, and for a turbulent flow, the value of capital F is given by 0.316 by Reynolds number to the power 1 by 4. Okay. So this was all about frictional loss or frictional head loss in a pipe. Okay. Now let's directly move to the question. So this particular question is a GATE 2023 question, a metallurgy question. Okay. So for a laminar flow through a smooth circular pipe, the relation between the friction factor and Reynolds number is what? So we know that uh, we have just read in this previous slide that frictional head loss will be given by FLV square by 2GD, right? So that will be in fact having units of length HF, where capital F for a laminar flow will be given by 64 by Reynolds number. And we also know that capital F is 4 times small f, which implies small f will be capital F by 4. So that will be in fact 16 by Reynolds number, right? So from this, option A is the right answer. So we could easily reach at the options because we have just revised the concept. So from here you can know that repeated revision is also necessary. Revision is itself necessary and repeated revision is also necessary. Okay. So the more you revise, the more the concepts will retain in your memory and the more you will be able to recall in the exam. So if you know the concepts, then you will be able to reach at the options quite fast. Okay. This way you will be able to save more time. So there is a kind of logical explanation. So this is the logical explanation to why we need revision. So this is how I will be in fact covering my revision series as well. We will be referring my own notes for the purpose of learning the concepts and revising the formulas, and referring to those, I'll try to integrate them with the previous year questions. Okay. So let's now directly move to what this course will contain. So these are the brief features of the course. First, it will consist of the formulas and short notes that will be based on the latest GATE Metallurgy syllabus. Next, the lectures will be based on the formulas and notes which I prepared during my preparation. So I'll be directly referring to those. Yes, you will be able to see the screenshots of the formula notes which I have prepared. So I'll be referring to those handwritten notes, just like I have explained here. The similar way I will be explaining to you in this revision series as well. And the referring to all those handwritten notes, you will also get to an idea, a brief idea about how should you prepare your notes so that they will be crisp and to the point, and you should not, and you will not be spending much more time on what to cover and what not to. Okay. So I have kind of filtered out the formulas for you. So I have written all the formulas which are possible and that may be asked in GATE. So some formulas are not yet asked in GATE. So there are some chances that they might ask the questions related to those as well. So have a thorough look at the formulas and notes which I have prepared. So that will also help you in the revision as well. Next, the revision series, of course, that will boost your preparation. And in between the series, I'll also share some tips and tricks that will help you to revise and retain the formula in your mind. So let's say if you have a very complex formula or a complex series or a list of things which you need to remember, there I will also let you know about the mnemonics which I used during my preparation stage, and you can as well. You can prepare your own, or else I will also share some of the tips and tricks during solving the previous year questions that will in fact help you to solve the questions at ease and a faster pace. Okay. So you can directly refer to those tips, or else you can make your own as well. So I will guide you through that as well. Next, the concepts will be integrated with previous year questions. This I've already told, right? So this will be the brief course flow in detail. Initially, I will begin with the numerical methods, and I'll be dealing with the general aptitude that will in fact have a numerical approach to that. Okay, so the questions like calendar questions or finding out the last digit of something number raised to the power higher number, right? So we will be dealing with how to solve those in the general aptitude section. Next, I'll deal with the engineering mathematics. There we will deal with linear algebra, calculus, vector calculus, differential equations, probability and statistics. Along with that, I will also discuss the numerical methods of differentiation and integration. Okay, next, in section 2, we will deal with the metallurgical thermodynamics, where we will deal with the laws of thermodynamics and electrochemistry in detail. Along with that, we will also look at the Maxwell relations and all those which are involved in the thermodynamics part. Section 3 will deal with transport phenomena and rate processes. Here we will deal with momentum transfer, heat transfer, and under heat transfer we have conduction, convection, and radiation. Mass transfer, dimensional analysis, basic laws of chemical kinetics. So all these syllabus are according to the GATE metallurgy only. I have not mentioned each topic in detail, but whatever topics are there in the metallurgy syllabus, I have dealt with them in detail inside this revision series. Okay, so I have written only the major topics here, and the order is exactly the same in which they have been mentioned in the GATE metallurgy syllabus, official syllabus. Okay, next, section 4 is the about physical metallurgy. So physical and mechanical metallurgy are the major chunk from where the questions are asked, so you have to deal with them very much cautiously. Okay, so physical metallurgy deals with chemical bonding, structure of solids, solid solutions, phase diagrams. So especially we will deal with iron carbon phase diagram. Next, diffusion in solids, phase transformations, heat treatment, a characterization of materials. Here we will deal with X-rays, SEM, TEM, optical microscopy, and all those electronic, magnetic, and optical properties of material. These are some of the minor topics. And along with that, we will also deal with basic form of corrosion and its prevention. Okay. Next, in section 5, we will deal with mechanical metallurgy. Here we will deal with stress strain diagrams, strain tensors, Mohs circle, dislocation theory, energy associated with the dislocations, types of dislocations, stress fields around dislocations, all those. Along with that, we have strengthening mechanisms about precipitation hardening, grain boundary strengthening, solid solution strengthening, and all those. Fracture, fatigue. Okay, so in section 6 we will deal with manufacturing process. Here we have 5 major topics: casting, metal forming, welding, powder metallurgy, and non-destructive testing. And section 7 will involve mineral processing and extractive metallurgy. So this is a vast topic, and mineral here we'll deal with the mineral processing, some unit operations involved in that. Along with that, we will also deal with the general methods of extraction, and we'll deal with non-ferrous metallurgy, especially extraction of aluminium, titanium, and copper. That is in fact mentioned in the GATE metallurgy syllabus. And along with that, we will deal with iron making and steel making. So iron making comes under ferrous extractive or ferrous extractive metallurgy, and along with that, we will deal with steel making as well. Okay, so this is the brief course flow which I'll follow during my revision series. And yes, that's it. So was all about the introductory session of this revision series. I hope you will like this series as well. That's it. Let's meet in the revision series again. So thank you.